Okay, so up until now, we've been dealing with things moving at a constant velocity, right? Like, this thing was just moving across here at a constant speed. And we also talked about acceleration. So we had lesson 9 that was mostly about things like, throwing up in the air and it come back down, right? And we talked about how when I throw this thing up in the air, it has a constant acceleration downward at negative 9.81 the entire time, right? Even when it's moving up. Okay, so now what we're going to have is actually a bit of both. So what I want you to think about now, though, is I'm going to have this. It's my kid's toy, actually. Um, if I push this off the table, you can think about up until this point, it's moving at a constant velocity, right? It's just kind of going across the table, and then it's going to drop off, and it's going to hit the ground. So if you're thinking about the motion in the x direction here, it's moving at a constant velocity. It comes off the table, and then it's going to start to drop, right? So we know from our other lesson that when this thing's dropping, it's going to be accelerating downward. But what about this way? So we've got two motions here. We got the motion of this thing accelerating downward, but in the x direction, the entire time, it's not accelerating at all. The velocity is exactly the same the entire way down in the x direction. We need to make sure that we're talking about in the x direction or in the y direction. Okay, so when this comes, accelerating downward, constant velocity this way. And this is going to matter because we have different formulas for something accelerating and something traveling at constant velocity. And that's my dog Merlin. Hey Merlin. Okay, so part 1 here, it says independence of vertical and horizontal motion. So that's what I was just talking about. How vertical motion is going to be accelerating, horizontal motion is going to be constant velocity. So in lesson 12, we were able to have, like a plane's direction going this way and the wind going this way. But in both these cases, they were going at constant velocity. So now what we're going to do is we're going to make it a little bit tougher by, well, here, actually I'll go through this first. So if you look at something being dropped straight down or something being kicked off to the right, if you keep track of this ball all the way across, like this ball is that one, this one is that one, this one is that one, they take the same amount of time before they hit the ground. And you might not think that that's true on the face of it, because you're like, well, obviously this one traveled a farther way, so it went farther. But that's not right. It actually did take the same amount of time to drop straight down, because it's only accelerating in the y direction, or in the up and down direction. Okay, so you can kind of see, here's another example of what I just did on the counter there. So projectiles that are being shot off a counter like this, you can see that you can think about this thing's velocity. You can see that its velocity is changing its direction all the way down. But the two vectors that make it up, the x and the y component, if we look at those, then the x component, the velocity in the x direction, it's the same size arrow the entire way down, because it has constant velocity the entire way down. And I can't stress that enough, because that's the big concept that everybody misses, is that the velocity in the x direction is the same the entire journey. It's the arrow in the y direction that changes. It's the one that gets longer and longer as it goes down, because it's getting faster and faster, just as if you drop something. So in the vertical direction, it's going to follow this formula, right? It's going to follow our more complicated formulas. In the horizontal direction, it's going to follow our simple formula, v is equal to d over t. All right, so if we look at example number 1, it says a rock is thrown horizontally, so flat, from a 100-meter high cliff. It strikes the ground 90 meters from the base of the cliff. At what speed was the rock thrown? And here it says a key to solving these is to split it up between the vertical part and the horizontal part, because they follow different formulas, right? And one thing that isn't written in these documents, but I've found a lot of really good luck with this with my students in the past, and I'd like you guys to do it too, because I guarantee you're going to find it a lot easier. Is you're going to make a table to begin with. So every one of these questions that has a projectile, you're going to have the x direction and the y direction. So that's going to be the top there, right? So everything in the x direction, there's only one formula for it. That's going to be v is equal to d over t. And we're going to write, so the only things that are going to go in the x are going to be v, d, and t. And that'd be vx and dx. Okay? And then in the y direction, the possibilities are all of those acceleration ones. So we're going to have vi in the y direction. We're going to have vf in the y direction. We're going to have t. And t is the same for both, right? That's kind of the big one. That's the big concept, is that for both x and y, the only thing that's the same between them is going to be the time. Okay, and you're going to have distance in the y direction, and then you're going to have acceleration in the y direction, but it only accelerates in one direction. Okay, so now that you have that table, it just makes everything a lot easier to kind of see what you're actually dealing with. So now, if we look here, it says, well, I'm going to draw a little picture too. Let's draw a picture for this one to make sure you know what all this stuff means. So we've got something, this rock, it's thrown off this way, right? And it's going to make a path something like this. Alright, so it says the height is going to be 100 meters. That's how tall the cliff is. It lands 90 meters from the base of the cliff. Alright, and what else do we know? We know, well, if I'm looking at this, I know a few things that you might not expect right off the bat. I know dy, and is it 100 meters? No, it is not. It's negative 100 meters because it's down, it's below me, right, to the ground. I know my acceleration due to gravity is negative 9.81 meters per second squared. I need three things though, right? And I'm looking at this, I'm like, okay, I don't know anything else in the y direction. Let's go back to it. So I also know that d is equal to, or dx is equal to 90 meters. And I'm looking for vx. That's what I'm looking for at the end. So you can kind of see now I can start to like work my way through this problem, knowing that time is the common factor between these two. So what you're going to do on most of these questions is you're going to figure out what time is and then use that to solve something else. So that's what we're going to do in this one. We need to find time. But I'm still missing something. And there's a key bit of information here. When I drop this, how fast is it going right when I let it go? Well, it's going 0, right? Right when I let it go, it's going 0. The same thing is true if this is coming off of a ledge. I don't have a ledge here, but if this is coming off of a ledge like this, it's going this way, and it's moving when it comes off the edge of that left. It's still moving to the right. It's moving in the horizontal direction, but its velocity in the y direction is still 0. That's a confusing concept for some people. So it's moving, it is still moving, but its velocity in the up and down direction is 0. Its motion is entirely in the x direction. So if my velocity is entirely in the x direction at that point when it comes off the cliff, then vi in the y direction is equal to 0. That's the missing bit of information there. Now I can just start with the formula for velocity. I'm going to use a formula that doesn't even have vf in it. That's because vf is the one that I don't even really care about here. I'm looking for t. So I'm going to say d is equal to 1/2 at squared. Is it plus or minus? Plus. Oh, sorry. D is equal to vit plus 1/2 at squared. Got a brain glitch there. All right, so that's what we're going to do, and that's dy, and this is vi in the y direction. And yeah, okay. So this is going to become a lot easier though, because vi in the y direction is 0. So this entire term goes away. Now our formula is dy is equal to 1 half at squared. And if I rearrange for t, we've got t is equal to 2 dy over a, and then take the square root of that. So t is going to be equal to the square root of 2 times, my distance was negative 100 meters. My acceleration due to gravity is negative 9.81 meters per second squared. So my time is going to be equal to 4.5 seconds. Now you can start to see how we're going to move through this thing. So I've got my time. I'm going to put it in red just so we know that's the first thing we found. So that was 4.5 seconds. Now time is the only thing that's constant between my x and my y. That's the only thing that links them together. So my time is the same for both. It's also going to be 4.5 seconds. So now I've got, if I look on my x side here, I've got distance and I've got time. Last thing I got to do is just go, where can I write this? Over here. Vx is equal to dx over t. So Vx is equal to 90 meters, and it's positive 90 meters because it's to the right, divided by the time I just found of 4.5 seconds. So my velocity in the x direction, so the velocity coming off of there because it was entirely in the x direction, is going to be equal to, what is it, 20 meters per second. Alright, so you can go ahead and do it this way if you like that way. I really do recommend making this table though. It will make your life easier. It's just an easy way to see how to move through these questions. Okay, I'm going to move on to the next one. Actually, you know what? I'm going to leave that one there because that's a good, this is a certain type of question. The next type of question we're going to do is if something is kicked up on an angle. So it just adds one more level of difficulty. So I'll end that video there.